Starting here with problem 2.6 on page 49. Roger Bannister running against Hisham El Garouge. All right, so in this sort of make-believe head-to-head race, because we want to know how far Roger Bannister would finish behind El Garouge. They actually ran 50-some years apart, 55 years apart. But we want to take the times that they had for the mile, which were record-breaking times at that particular point in history, and see how they compared in a make-believe head-to-head race. All right, so each of them had to run what we'll call big X. Big X is 1 mile. All right, so Roger Bannister's average velocity, and I'm just going to leave off this the bar that means average just for the sake of simplicity, was equal to this big distance, right? The whole distance, 1 mile, divided by his time. For El Garouge, his speed was, average speed was the mile divided by his time. Okay, but his time was less. El Garouge's time was less. So what we'll really find out is that Roger Bannister would have run a shorter distance, okay? He wouldn't have completed the whole mile in the amount of time that it'd take El Garouge to finish his mile. So what we're looking for, what we're trying to solve for, is this delta X, the distance behind El Garouge that Roger Bannister would have finished. All right, so here's XB, the distance that Roger Bannister went, right here, and here's big X, El Garouge, because he finished the whole race. All right, so now coming down here, we're going to just look at our drawing, and we can see what we call delta X right here can be written as big X, the mile, minus the distance that Roger Bannister run. That's what the difference is of this delta X. All right? So now, coming down here, we know that and in general, any velocity, by definition of average velocity right here, is delta X over delta T. So if we rearrange that, we can see that delta X, or in this case X, because we're just saying we start from 0, is equal to average velocity times time. And I'm dropping the delta notation also because times 0 will take to be 0. All right, so if this is our general expression, then this is true for Roger Bannister. Okay, how far he would have run in the make-believe race is equal to his speed times El Garouge's time, because this is how long El Garouge took to finish the race. Where would Roger Bannister have been at that particular instant? So coming down here, here's our delta X. We just write delta X is equal to X minus XB. This is Roger Bannister's distance here. We just wrote it based on the substitution from this expression right here. We just took XB, and now we replaced it with VB TG. All right? So now, what we got to figure out is time in seconds, because you can't use minutes and seconds at the same time. So just straightening all that out. So now we take a look at what do we have for Roger Bannister's velocity? How are we going to calculate his velocity? Well, his velocity, his average speed, was actually the whole mile right here over his time. Okay, that's how fast he ran, and that was based on his running of the race back in 1954. All right, so we're going to take his velocity here and multiply it by El Garouge's time to get the total distance that Bannister would have run. From that, we'll subtract the whole mile, or we'll subtract that from the whole mile to see what the difference was between them at that given time. So now converting minutes to seconds, we know that 3 minutes times 60 seconds per minute gives us 180 seconds here, plus 59.4. This is from the data given in the problem. It means that Roger Bannister's time was 239.4 seconds. All right? By the same logic and all that stuff, we're going to find that El Garouge's time was 223.13 seconds. All right, so now, all we have to do the rest of the way is a little bit of algebra. So we're just going to rewrite this expression right here as X times this ratio. You can see we got the X out here, and we have 223.13 over 239.4. Seconds cancel out, so this is a dimensionless ratio right here. So we got distance, 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 so everything will work out dimensionally. So now we just pull the X out. That makes things easy for us. So we have X, I'll pull this out, X times 1 minus this ratio right here. So now, knowing that 1 mile is equal to 1609 meters, We just replace that with, instead of writing in 1 mile and then converting, let's just write in the conversion to begin with. All right, times 1 minus that ratio right there turns out to be delta x is equal to 109.4 meters.